review for the quiz. So a company delivers apples to a grocery store, and they have certain quality standards. They don't want blemishes of more than 9%. This should sound very familiar. It's basically the potato problem all over again. So supervisor selects a random sample of 500, finds 55 of the apples have blemishes. We're going to do a significance test where P is the true proportion of apples with blemishes in a given truckload. So that's done for you. Alpha at 0.05 to test quality standards. Okay? So, step 1. Whoops. Right there. Again, it was given. You can even shorten it more. Proportion of apples that are blemished. Remember, if I go too fast, just hit pause. So you get that right out of the problem. Very nicely given to us. Okay, our N, the number is 500 in the sample. P hat is the number we actually have out of 500. Remember, it's like on a test. There's 500 points in the test. You got 55 right. That's an 11%, 0.11. And alpha was given to us at 0.05. Number 2, part 2, step 2, whatever. Okay, is it normal? That was given to us. Okay, so instead of saying random, we say normal for these tests. So n times p and n times 1 minus p. So 500 times 0.11. So my n is 500 times 0.11, and then 500 times 1 minus 0.11. Okay. Both have to be greater than 10. And it's 55 and 445, so we're good to go. Now, step 3, state your ho and your ha. So, ho has got to be 0.09, right? That's the limit. And p greater than 0.09. In other words, we don't want more than 9% blemishes. Step 4 and 5. Z equals p hat minus p divided by the square root of p times 1 minus p divided by 500. That gives us 1.56. So over here at 5, you have a nice little graph of where 1.56 would be. And if you look at your chart, you're going to find out it's 0.0591. Remember, that's not what the chart's going to give you. You have to do 1 minus to get that. Okay? Anyway, you're probably just going to sketch it out like this. You go 0, 1, 2, 3, 1.56. You know, that's all you need to do. It's not that big of a deal. Okay? Then, step 6. We're going to compare the p-value, which is 0.0594, or 591. That's a typo. Okay? All right. Doesn't really matter. 2.05. Well, it is bigger. Slightly bigger, but it is greater than. So, we fail to reject the ho. We do not have convincing evidence that the proportion of apples that are blemished are greater than 9%. So again, this is the format. You just copy it each time. Now, going on to our new stuff that we learned, what would be a type 1 error and a consequence? Okay? So type 1 error would be saying that the proportion of apples with blemishes is greater than 9% when it really is equal to 9%. The consequence is the truckload of apples would have to be sent back to the supplier. All right? That would be cost to the farmer, cost to the transport company. I'm not sure what the contract is, but those kind of consequences. A type 2 error would be saying that the proportion of apples with blemishes is equal to 9% when it's really greater than 9%. That would mean that a lot of the apples in the stores are more blemished. You have more blemished apples. Which is worse? Neither is terrible. Okay? If you're the apple farmer, type 1. If you're the consumer or maybe the grocery store, type 2. It's one of those things where if you argue it well, I'll accept either one. Okay, second question. Major urban area, percentage of male drivers between 19 and 29 who did not use seatbelts was 28%. After a major radio and television campaign and stricter enforcement by the local police, they want to know if the percentage in the same age range decreased. The poll sampled 100 males in that age range and found out 24% did not wear the seatbelt. So we're going to do a 0.05 significance test and see if it's decreased. So step 1, P is the proportion of male drivers between 19 and 29 who don't wear their seatbelt. Comes right out of here. Okay? You just take it right out of there and say proportion of. That's it. N is 100. Okay? P hat, 0.24. And then our alpha was given to us. Now remember, we, in the previous one, had to calculate the p-hat because we were given how many out of the 100, or 500. This one, they could have said 24 males out of 100, and then you have to divide. They just gave us 24%. Same thing, just didn't have to do the calculation. Step 2, normal, given, boom, good to go. Estimation point, check mark, whatever you want to do. Check for large numbers. 100 times 0.24 is 24. 100 times 0.76, which is 1 minus 0.24, is 76, both greater than or equal to 10. Remember, here's how much your candy cost. You paid $1. Your change is going to be 0.76. $1 minus 24 cents. Okay, board, come on. There we go. Hoe in the hob, all right? Your hoe is 0.28% because that's initially in the problem it said they found out that the percentage was 28%. And then we're looking for less than. We're looking to see if it decreased. Our Z score is going to be P hat minus P. You can see right there off the bat that it's going to be a negative number. Which means when we go to our table, we can just use the number on our table. So it's P hat minus P, divided by the square root of P times 1 minus P, divided by 100. Here's our Z-score. Here's what it would be if we drew it. Again, remember you're just going to do this, 0, -1, it's going to be like right here. Negative 0.89. So you're just going to sketch it out. Doesn't have to be perfect. Okay? And that's an area, or P, of 0.1865. Okay? Remember, this number is going to be on the chart because it's less than. So there's no 1 minus there. 6, since my p-value, 0.1865, 1867, I don't know what the deal is there, is greater than alpha. This time we fail to reject the hoe. We do not have convincing evidence that the proportion of male drivers between 19 and 29 who don't wear their seatbelts is less than 28%. Okay? And you get that from right here. Okay? We fail to reject the hoe. Okay? So we're saying no to this. We don't have evidence to support that. Okay, type 1 error. Say the proportion of male drivers who do not wear a seatbelt is less than 20% when it's actually 28%. A consequence is they don't spend the money to do the radio and television campaign when it's really needed. So they think it's working when it's not, and they stop doing the ad campaign. Type 2. Saying that the proportion of male drivers is 28% when actually it's less than. Well, the consequence is they spend money and it's not needed because it's already done its job. Which is worse? The type 1 error is worse in this case because male drivers could get injured in an accident if they do not have their seatbelt on. And that's it.